Okay, guys, this is a quick lesson on how to graph linear inequalities in two variables. Just as a little review, when we had a problem like this, you don't have to write it down, but just listen. When we had a problem like this earlier in the year, we had y plus 2 is less than 8. And the way we solved that was, of course, subtracting, got y by itself, and that's going to be less than 6. Well, the way you symbolize your answers, all the solutions to that, you put it on a number line. So you put it on a number line, and you had 6, and you had 5, and 7. And then you remember, okay, how are you going to symbolize all your solutions? Well, it was less than with not an equal to, so you had an open circle, and then you had all the numbers that were less than 6. So you graphed it on a number line. You represent your solutions on a number line. Well, the difference now is that, okay, you had one variable. Now you have two variables. And so this is similar to if you were here the other day, we did some problems as groups, and we were just looking for all the solutions. We're not going to talk about this today, but we were looking for all the solutions that can make it happen. Well, with two variables, you have multiple solutions that can make that true. So we need to look at a couple things. A lot of the skills that you need to make this happen, you already have. You're just putting them all together and understanding what your solutions, what your graph is representing. So what this is saying is y is greater than or negative 2 times x. You're looking for ordered pairs that make this true. Okay? So the first thing you want to do is make sure that you have your equation written in slope-intercept form. The first thing, because it's easier to graph your line. So you're going to first graph, after you slope-intercept form, you're going to graph your line as if it's in slope-intercept form. Here, your y-intercept is 0. So you have 0, and your slope is a negative 2. So you have negative 2, down 2 and to the right 1, or up 2 and to the right 1, or left 1, up 4, 1, 2, 3, 4, and over 2. So you're going to graph 1, 2, 3, 4, 1, 2. I can't talk and do this at the same time. Okay, use your note card. Now here's the deal. You got to be careful. Just like up here, that less than equal to means something, like you had a closed circle if it was equal to. This one, pay attention, it's not equal to. And so we are not going to have a solid line. If it has a solid line, if it's a greater than, equal to, or less than or equal to, it's going to be a solid line. If it is not, it's going to be a dashed line. So this is saying that these points are not, they don't make the statement true, but this is what we call our boundary line. So we're going to have a dashed line, because we're saying that that's our boundary line. This is really called a boundary line. Okay, now we got to decide which are true. So you're going to test a point. You're going to pick a point. I wouldn't say on the line. So I would say pick a point off the line to see if it's true. Okay, so I would test 0, 0 normally, but this is going through the origin. So I would test maybe an easy point to multiply. I would say 1, 1. So if you test 1 for y and 1 for x, 1 is greater than negative 2, that is true. So 1 is greater than negative 2, that means that is a solution. So you're going to shade this whole side. You're going to shade this whole side and saying that all of those ordered pairs are solutions that make that true. Okay? X is less than or equal to 3. This is where many people mess this graph up. You're saying x is 3 no matter what. Y can be negative 2, it can be 0, it can be 2. So that is a positive 3. So your line is going to be going vertically, and it's equal to, so it's going to be a solid line. Okay, now test. X has to be less than 3. So that has to be like 2 is less than 3. So your x values have to be less than 3. So all of these would work. Shade to where it's dark enough to tell which side you shaded, light enough to still see the background. Because when we do graphing of more than one inequality, you need to see where it overlaps. Okay? So you're representing all those solutions. Okay, I'm going to jump down to this one because I want to remind you about when you are solving your inequalities. This one's not in slope-intercept form. So yes, you're going to change it to slope-intercept form, but here's what you have to remember. Dealing with inequalities, when you divide or multiply by a negative, You got to remember you need to reverse the sign. So when you divide by this -3, you need to reverse the sign. Now it's equal to, so don't forget that. Now watch this. -4 and -3, that simplifies down to 4/3 x. That's a -3, so -4. Then you're going to graph it. So all of these skills you have known, now you're just putting them all together and showing that the solution, there's many solutions to this inequality. Okay, so -4, 1, 2, 3, 4, positive 4/3. Remember, you're going to, that top number, that's your rise or run, your rise, and your bottom number is your run. Okay, and use your note card then. No, careful, it is a solid line. That's what I always look at. What's nice about it, if you make a solid line just on because of habit, it's easy to fix. Take your eraser and just mark, like erase part of it. All right, now, test a point. I like to test 0, 0. 0, 0 is the easiest point to test. You can test it here or you can test it here to see if 0, 0 works. So if I put in, so I'm going to test. Now you can do a lot of this part mentally. I'm okay with that. And 0 is less than or equal to 12. So 0 is a solution. So 0, 0 is a solution. So that means all of this part of it is going to be shaded in. So you're going to shade all that side in. Okay, so that's what you're doing. Your homework is going to be a page like this. So graphing linear inequalities, there are 6 on the front, 6 on the back. Just be careful when you change it to slope-intercept form. Be careful here. Remember that is the -1. You got to get rid of that. So you got to flip your sign. So be careful there. So that is your homework for Thursday, whatever date this is, January 26th. Thank you.